Brihat-net is our proposed deep learning architecture, mathematical model, and algorithm that models dynamics interaction patterns in various spatiotemporal networks. We would be able to model vehicular mobility patterns, supply-demand, power grid supplies, warehouse management, etc., based on the given attributes such as socioeconomic, environmental, geographical, commercial, and other relevant features. The proposed model will be used for different downstream prediction or planning tasks. Our proposal addresses a couple of issues with current models. Graph neural network, GNN models are computationally expensive and struggle to capture the directional distribution of the traffic required to capture mobility patterns in various networks. Addressing the latter issues would result in better ETA estimations for vehicular traffic, supply chains, etc., while addressing the former would improve prediction models for supply-demand, power grids, computer networks, etc. Graph data or network structure data is non-Euclidean in nature, but the spatiotemporal network has at least one dimension that can be approximated to be Euclidean, that is, space. We will exploit this property of spatiotemporal networks to devise a convolution operation that helps correlate all network nodes by propagating information like CNNs. In addition to that, we will also use a shallow GNN layer to capture non-Euclidean network structure. This allows us to quickly accumulate or convolve throughout the network at a reduced computation cost and will enable us to have a directional distribution of the network dynamics. What problems do we solve with this? We solve two kinds of problems: prediction problems and planning problems. Some of the prediction problems can be: how do network interaction dynamics evolve? How does a change in network structure affect the resultant network interaction dynamics? Identification of motifs or subgraphs with strong interaction, spatiotemporal supply-demand, class volume, etc. Predictions. The second part is the planning part. What kind of plans can we develop with this? Given the prediction model that provides us with the interaction attributes on a given graph, we can identify or generate routes, sequence of links. In the public transportation network, we can use it for vehicle scheduling and route finding/routing given the resource constraints, fleet size, available staff, working hours, etc. We can use it in urban planning for transport networks, communication transmission lines, etc. In e-commerce and logistics, it can be used for warehouse/inventory management. In healthcare, it can be used for planning and predicting medicine supply demand, pandemic spread patterns, etc. In electric grids and power transmission, demand prediction and planned load shedding. It can also be a preemptive control unit to save from overload damages. In communication networks for planned frequency and resource allotment and sharing.